Our oceans are under threat. CO2 levels are rising, negatively impacting our global temperature, but also our oceans, marine life, and marine ecosystem. If the high rate at which we expend CO2 continues, our oceans will bear the consequences. Since the Industrial Revolution, atmospheric CO2 concentrations have skyrocketed. The current carbon concentration is 410 parts per million, the highest concentration in 800,000 years. Increasing atmospheric CO2 levels are caused by a variety of human factors. For instance, the burning of fossil fuels, deforestation, and the agricultural industry. These increased CO2 levels will contribute to the warming of our planet. All CO2 does not remain in the atmosphere. However, carbon is circulated between the atmosphere and the ocean by means of the marine carbon cycle. Every year 92 gigatons of CO2 is dissolved into the top layer of the ocean from the atmosphere. This is 30% of the total atmospheric CO2. Once the carbon is in the ocean, it is then metabolized by phytoplankton using energy from the sun. After that, the carbon will eventually drop to the ocean floor or end up back in the atmosphere. Per year, 2 gigatons of this CO2 sink to the ocean floor in snow-like flakes, creating sediments. The remaining 90 gigatons of CO2 are released from the ocean surface back into the atmosphere. Counterintuitively, carbon absorption into the ocean occurs most efficiently at cooler sea surface temperatures. This concept can be visualized as a cup of soda going flat on a warm day. As global temperatures and sea surface temperatures increase, it gets harder for circulations to mix the lower ocean layers with the top layer. This results in a phenomenon known as stratification, when the ocean breaks down into layers. Each stratified layer has a different density, temperature, salinity, and pressure. Since 1960, stratification has increased by 5.3%. This stratification means that the top layer of the ocean cannot receive new nutrients and minerals from lower layers of the ocean in order to react with CO2. This leads to the top layer of the ocean becoming saturated, or full, so the ocean absorbs less CO2. With increased concentrations of CO2 in the atmosphere, comes a decreased capacity of the ocean to hold that CO2. This contributes to the increased acidity of the ocean. Since the Industrial Revolution, the ocean has become 30% more acidic. High acidity levels are detrimental to coral reefs, shellfish, and much more. We've discussed the atmosphere's increased CO2 levels, the decrease in the ocean's ability to absorb carbon dioxide, the stratification of the ocean, and the ocean's increase in acidity. But why does this matter? To start, a decrease in CO2 absorption into the ocean coupled with increased emissions will contribute to planetary warming that will negatively affect quality of life. Additionally, as ocean temperatures rise, plankton populations will diminish, as they function better in cooler temperatures and require nutrients from lower levels of the ocean that will no longer be accessible due to stratification. This will ripple up the food chain and result in reductions in a variety of marine species. Similarly, as the top layer of the ocean becomes more acidic, coral has fewer minerals available to build with. Coral's skeleton becomes more fragile and thin, as do the shells of various other marine life. Many coastal regions reliant on fishing industries will suffer as a result of weaker shellfish and smaller plankton populations. This will also limit access to many people's primary source of protein. Tourist industries will also be negatively impacted by weaker marine life. For instance, scuba diving and snorkeling businesses. If we don't make changes to our carbon footprint soon, many parts of the atmospheric and marine environments will begin to show the devastating signs of our negligence.